What if the coldest, driest, most desolate place on Earth used to be a tropical jungle filled with dinosaurs? Before it was ice, Antarctica was alive. And buried beneath kilometers of frozen silence is the story of a lost world. Hidden in the dark, isolated bottom of our planet lies its harshest and most alien continent, Antarctica. It's a frozen desert bigger than Europe, sitting on a giant block of ice that holds over 90% of Earth's total. Along its high cliffs and rugged coasts, life thrives without pause, ranging from birds and plant life to mysterious deep-sea animals. But deep inside the continent, the environment is so brutal that only microbes can manage to survive. Beneath its lifeless surface, fossils and relics remain from an era when Antarctica looked nothing like it does today. Instead of ice, it was once blanketed by forests filled with all kinds of ancient creatures. That ancient world is now lost, buried under miles of unmoving ice. Yet, thanks to cutting-edge technology developed over the past century, we've been able to peel back its frozen layers and uncover Antarctica's hidden history, showing how it shifted from a lush, temperate cradle of early life into the world's largest desert, Antarctica. Situated at the South Pole and often shrouded in endless darkness, Antarctica is Earth's shadowy no-man's land, the only continent without any permanent human residence. Unlike the Arctic, where numerous communities live within the surrounding nations. But while the Arctic is an ocean ringed by land, Antarctica is a land mass encircled by ocean, making it far more remote and harder to reach. That's why it remains the only continent with no nations of its own. Even though some countries claim wedge-shaped sections of it, those claims carry little weight without people living there to support them. Especially during winter, Antarctica's conditions are far too extreme to support thriving life. Instead, most native species here are extremophiles like bacteria, fungi, moss, and lichen that have evolved over millions of years to survive intense cold, minimal sunlight, and near total dryness. These traits make them fascinating comparisons for what life might look like on Mars. In contrast, more complex life forms are found mainly along Antarctica's coastal regions. From its many iconic penguin species to 3-meter-long leopard seals that prey on them, plus over 100 million birds that come to nest here in spring. Meanwhile, the waters around Antarctica are teeming with biodiversity, just as its interior is barren and lifeless. This richness stems from the interactions happening in the Antarctic Ocean, which spans the lower fifth of the southern hemisphere. The Southern Ocean forms where warm currents from the Atlantic, Pacific, and Indian Oceans collide with Antarctica's icy waters. These interactions, combined with Earth's rotation, trigger upwelling, where deep, nutrient-rich water rises to the surface. This upwelling feeds seasonal phytoplankton blooms that serve as the foundation of Antarctica's massive marine food chain, supporting life from shellfish and sea spiders to octopuses, giant squid, orcas, fin whales, humpbacks, sperm whales, and even the largest animal on Earth, the blue whale. Moreover, this upwelling off Antarctica plays a major role in stabilizing the balance of Earth's oceans. It drives a global oceanic conveyor belt. Thanks to the Antarctic Circumpolar Current, the strongest ocean current on the planet, which carries warm water around the world. But this west wind drift also acts like a protective moat encircling Antarctica. It fills nearby seas with a ring of violent storms, locking the land in a swirl of bitter cold winds, far more brutal than those in the Arctic. At the North Pole, temperatures can dip to minus 40 degrees Celsius, but in Antarctica, they're often nearer to minus 60 degrees Celsius on average. The coldest temperature ever recorded on Earth, 89.2 degrees Celsius, was logged in Antarctica's icy desert by the Soviet Vostok Station in 1983. And in 2010, satellites detected an even colder reading, minus 93.2 degrees Celsius. These extreme temperatures cause nearly all of Antarctica's water to freeze solid like rock, letting millions of years of snowfall build up across the land, covering over 98% of Antarctica's land beneath a thick layer of freshwater ice, rising higher than even some of the continent's own mountain peaks. The ice averages about 2 kilometers thick, and in some areas reaches nearly 5 kilometers. This ice sheet makes Antarctica the highest continent on Earth, also the driest and hardest to reach. It holds more than 2/3 of the planet's entire supply of fresh water. If it all melted, sea levels could rise by over 50 meters globally. Without its icy cover, Antarctica would look like two tectonic landmasses. The eastern side is a huge, mostly flat plain about the size of Australia, bordered in the west by a cluster of young mountain ranges and volcanic island chains, created by the same tectonic forces that shaped all 7 continents. The northernmost of these regions, just 1,000 kilometers from the southern tip of South America, is the Antarctic Peninsula and nearby islands. It's among the mildest and easiest places to access in all of Antarctica. Because it's farther from the South Pole, summer temperatures here can rise above freezing, making it a hot spot for biodiversity and a key site for biological and climate research. Stations like the US's Palmer Station, the UK's Rothera facility, and Argentina's Base Esperanza, where the first native-born Antarctic citizen, Emilio Palma, was born in 1978, are all located here. But what truly sets this region of West Antarctica apart is its mountain ranges. Mountains are created by massive tectonic movements deep inside the Earth. And these Antarctic mountains closely resemble the southern Andes, located just beyond the Drake Passage. Their age and geology suggest they were once part of the same range, meaning the Antarctic Peninsula may be a long-lost extension of South America. On the other side of the peninsula near its base lies the Ellsworth-Whitmore region, which holds Antarctica's highest mountain, Vinson Massif, rising to about 4,900 meters. This range also resembles South Africa's Cape Fold Belt in geology, pointing to a historic physical connection between these 3 far-apart continents. In fact, even more astonishing geological evidence exists on Antarctica's eastern side. It's a huge, high-altitude desert resting on an older and larger piece of stable continental crust. Today, almost nothing except microbes can endure the conditions there, but mountains poking through the ice have revealed fossils from a time when life was much more widespread across East Antarctica. North of that lies Queen Maud Land, a 2.6 million square kilometer mountainous region claimed by Norway. Many of the rocks there are over 1.2 billion years old. They share characteristics with rocks in Africa and India, once again supporting a deep geologic connection between today's distant continents. Meanwhile, the southern edge of East Antarctica is home to one of Earth's longest mountain ranges, the Trans-Antarctic Mountains, with peaks over 4,500 meters tall. One of them is Mount Kirkpatrick in the Queen Alexandra Range. Since it isn't heavily covered in ice, its rock is easier to dig into. That's how scientists in 1991 stumbled across a fossil graveyard filled with the remains of an unexpected former resident, dinosaurs. The Hansen Formation is now considered one of the world's most important fossil sites. It has yielded many dinosaur fossils from the early Jurassic era. species that seem to have existed only in Antarctica. But none of these animals could have lived there if East Antarctica had always been frozen at the South Pole. Instead, these dinosaurs roamed Antarctica when it was ice-free and located in a more favorable spot on the early Earth. Back then, it sat between Africa, India, and South America as part of the massive ancient supercontinent called Gondwana. Roughly 500 million years ago, Gondwana brought together much of what we now call the Southern Hemisphere. It included all of Africa, South America, Australia, India, Madagascar, and, of course, Antarctica. It was a single landmass that stretched over 100 million square kilometers. In this ancient supercontinent, both halves of East Antarctica were attached to Africa and Australia. Meanwhile, the younger and more tectonically active West Antarctica lay next to South America. And just like those neighboring continents, ancient Antarctica was blanketed in thick forests. Home to a vast array of ancient plants and animals, many of which have been discovered in Antarctica's fossil record. On the north side of the Queen Alexandra Range, early Antarctic explorers found fossilized remains of strange seed-bearing fern-like plants. These plants were from an extinct type of ancient tree called Glossopteris, which once thrived across the continent. Fossils of this tree have also been found in Africa and India. This groundbreaking discovery added solid proof for the 20th century theory of continental drift, alongside the astonishing realization that Antarctica used to be a lush, life-filled landscape. Covered in a fern and conifer ecosystem it shared with its neighboring continents when they were joined together. But that lush world wouldn't last, because about 180 million years ago, Gondwana began splitting apart from the inside. Hot magma rising from deep below began weakening the continent's crust. Over the next 100 million years, East Antarctica slowly drifted away from Africa, India, and Australia. At the same time, West Antarctica was pulled away from South America, creating the Drake Passage. Around 50 million years ago, Antarctica had fully separated and was drifting over the South Pole. This made the continent even more isolated as it became trapped inside a polar vortex. That led to plunging temperatures, less daylight, little liquid water, and a massive decline in life. By 30 million years ago, Antarctica's rich forests had turned into dry tundra and low shrubs, and its ecosystems were reduced to extremophiles like moss, algae, and fungi. By 17 million years ago, snow and ice had built up in the valleys, turning them into glaciers, which kick-started the creation of the Antarctic ice sheet, burying the continent's once vibrant ecosystems under countless layers of solid ice. Just think about the fossils and secrets we might discover if we could dig beneath the thick ice shield covering Antarctica today. The Beardmore Glacier, where many ancient fossils were discovered, is located on the southeastern edge of the Queen Alexandra Range. This range extends roughly 200 kilometers into the Ross Ice Shelf, a France-sized floating glacier and the largest of its kind on Earth. Near its edge lies another of Antarctica's wonders, Ross Island. Discovered in 1841, this large volcanic island at the foot of the Trans-Antarctic Mountains acts as a natural gateway to the South Pole. Early 20th century explorers climbed it to reach the East Antarctic Plateau. During the heroic age in the early 1900s, many explorers embarked on bold and dangerous missions to Earth's poles. And Ross Island often served as their crucial launching point. From 1901 to 1904, the British Discovery Expedition, led by Robert Falcon Scott and joined by Ernest Shackleton, reached the southernmost point ever recorded at that time. they arrived at the base of the Great Ice Barrier, now the Ross Ice Shelf, and set up a small base on Ross Island for future missions. Years later, both men launched separate, ill-fated expeditions to become the first to reach the South Pole in 1908. Shackleton was first, landing his ship Nimrod at Cape Royds. He began a bold sled journey that took him far into Antarctica's frozen wilderness. He and 3 companions came painfully close to reaching the South Pole, but they had to turn back just 180 kilometers short, lacking supplies and pushed to their physical limits. As Shackleton put it, "A live donkey is better than a dead lion." His old captain and now rival Robert Falcon Scott would come to deeply regret those words. As he launched his own mission to the South Pole, the Terra Nova expedition. 3 years later, on November 1st, 1911, his team ascended Ross Island. Not knowing that Norwegian explorer Roald Amundsen had already left from the Axel Heiberg Glacier a month earlier. Unlike Scott's team, who collected data while making most of the journey on foot, Amundsen's crew moved faster using a smart combination of dog sleds and skis, which let them travel over 65 kilometers each day. They reached the South Pole on December 14th, 1911, easily beating Scott's team, who stumbled in battered and starving on January 17th, 1912, only to find a Norwegian flag and letter waiting for them. Proof that Amundsen had gotten there first. Scott's journal entry that day is heartbreaking to read, and he kept writing emotional, gut-wrenching notes until shortly before dying in late March, when he and his remaining teammates were lost to a deadly Antarctic blizzard. In the 100 years since the South Pole race, our knowledge of Antarctica has grown immensely, thanks to breakthroughs in flight, radar, aerial imaging, and sonar mapping. These tools have revealed details about the continent's once mysterious geography and terrain like never before. They've even uncovered mountain ranges buried deep under the ice. Most of these advances came after World War I, when the U.S. emerged as the main force in Antarctic exploration. Supported by a powerful Air Force and Navy. From 1929 to 1958, the U.S. launched a series of complex missions to map Antarctica and pick sites for its Little America research stations. Each base achieved notable Antarctic firsts during their time. In 1934, Little America 2 became the first to send radio signals over 18,000 kilometers back to the U.S. mainland. During Little America 4 in 1946, 25 planes and 13 Navy ships took over 49,000 photographs of Antarctica. Little America 5, founded in January 1956, was one of 7 U.S. Antarctic bases built for the International Geophysical Year, a global push for scientific cooperation. Another base, McMurdo Station, has since become the main U.S. hub for Antarctic logistics and research. McMurdo is Antarctica's biggest base. Sitting near Ross Island at the entrance to the South Pole, this mini city of over 80 buildings can house up to 1,250 people at once. It's equipped with labs, repair shops, gyms, libraries, cafes, stores, and many other modern amenities. Each summer, about 150,000 meals are served to over 1,000 people per week. During the dark, lifeless winter, only around 200 people remain. Mostly engineers and support staff, not researchers or adventurers. Once a year, the U.S. Coast Guard delivers over 5 million kilograms of supplies to the station. Everything from machinery and building parts to medicine and dried food is included. The rest gets flown in when weather permits, often arriving with scientists eager to explore Antarctica for themselves. At McMurdo, researchers study everything from Antarctic geology and biology to glaciers and climate patterns. Located on McMurdo Sound, the southernmost natural harbor on Earth, the station is near many major Antarctic research sites. One of the most remarkable features nearby is Mount Erebus, the southernmost active volcano on the planet. Towering at 3,800 meters, it's one of the few remaining active volcanoes in Antarctica. Its summit holds one of Earth's few continuous lava lakes still bubbling today. Surrounding Erebus are 3 extinct volcanoes, including 3,200-meter-tall Mount Terror. Both were named after ships from Sir James Clark Ross's 1841 expedition that discovered Ross Island. Across McMurdo Sound lies one of Earth's harshest environments, the McMurdo Dry Valleys. These are a series of mountain valleys west of the Transantarctic Range, mostly protected from wind and moisture blowing in from the coast. That makes them one of the driest deserts on Earth, and the closest match we have to the surface of Mars. Mars shares these traits too: intense dryness, frigid deserts, and strong UV radiation. That's why the survival methods of the few extremophile microbes living here are of great interest to astrobiologists who hope to understand what life might have looked like on ancient Mars. Across Antarctica, other similarly alien places provide glimpses into what conditions may be like on other worlds. Deep in the East Antarctic Desert stands Concordia Station, run by France and Italy and nicknamed Dome C. It's used by the European Space Agency to train astronauts for long-duration space missions. Since it's one of the coldest, most isolated places on Earth, it naturally simulates the environment astronauts face during deep space travel, making it a perfect Earth-based lab to study how isolation affects sleep, mood, and immune systems. More routinely, the station drills deep ice cores to reveal over 1 million years of perfectly preserved climate data. Antarctica is also one of the best places on Earth to study meteorites. Meteorites are scattered across its plains, easy to spot, and incredibly well preserved. One especially notable meteorite, ALH 84001, was found in 1984 in Allen Hills. It's a 4 billion-year-old rock that scientists believe came from Mars. In 1996, scientists reported strange markings inside the rock. That looked like fossilized microbes similar to ones found in rocks on Earth. The possibility that a life-harboring meteorite came from Mars created a brief global sensation. Even U.S. President Bill Clinton commented on it at the time. Sadly, later and more detailed research has mostly disproved this idea. Scientists now believe those marks are better explained by natural, non-living processes. Antarctica doesn't just offer environments that resemble Mars. Deep beneath over 4 kilometers of ice in the Antarctic plateau lies Lake Vostok, the biggest of Antarctica's 675 known subglacial lakes. It's been sealed off from the atmosphere for tens of millions of years. Any microbe surviving beneath its ice might offer real-life models for what life might look like under the icy shell of Europa, Jupiter's potentially habitable moon. But since it lies so deep below the nearly impenetrable ice, Lake Vostok is still a remote frontier, just out of reach of our current technology. For now, at least, the eastern Antarctic ice sheet remains stable and will likely keep hiding some of the continent's most fascinating ancient secrets. The West Antarctic ice sheet, however, is much thinner in comparison, averaging just about 1 kilometer thick, making it far more sensitive and likely to melt irreversibly as global temperatures increase. In fact, scientists studying West Antarctica have already documented several serious cases of abnormal glacier retreat. with effects that could impact not just Antarctica, but the whole planet. Thwaites Glacier is one of the most important examples of this. Often called the weak underbelly of the West Antarctic ice sheet, it drains into a 45-kilometer-wide ice shelf that acts like a natural barrier. In 2022, scientists spotted large diagonal cracks stretching across nearly the entire shelf, alongside a noticeable increase in glacier flow detected by satellites. These signs suggest that the Thwaites ice shelf is starting to fall apart, and it could completely collapse within as little as 10 years. Meltwater from Thwaites already contributes roughly 4% to global sea level rise. But if the shelf collapses, the glacier's melt rate could triple, causing sea levels to rise another 5%. And if the entire glacier eventually collapses, which could happen in a few centuries, that alone could raise sea levels globally by over 65 centimeters. Even more alarming, these cracks might trigger fractures throughout much of the ice sheet. Warmer, salty seawater is already seeping into the cracks in the Thwaites shelf, which lets it reach under neighboring glaciers and possibly destabilize large sections of West Antarctica's entire ice shelf system. Simply put, if Thwaites Glacier breaks apart due to these cracks, it could trigger a domino effect, collapsing much of the West Antarctic ice sheet. While it wouldn't cause the catastrophic 50-meter sea level rise linked to melting East Antarctica, losing West Antarctica would still raise sea levels by 3 to 5 meters globally, leading to major problems for coastal cities and communities around the world. It highlights just how critical it is to protect our vulnerable societies and ecosystems from this rapidly changing world. As we've seen, Antarctica was mostly ice-free for much of its history, and no matter what the future brings, it may return to that state again. But remember, Antarctica wasn't always like this. For millions of years, it was alive and thriving. And if the ice melts again, our entire world could be changed forever. The question isn't if, it's when, and how ready we'll be. And on that wintry note, I thank you very much for watching this video, and I bid you good night.